Hello, my lovely viewers. Welcome again to Mathematics and I. It is your presenter, Jefferson, and today on the board we have a new topic known as variation. Now, this is a topic most students find difficult to understand. Now, I can say that variation, from the name as it implies, it talks about varies, how something relates with each other, how something differ, how they are related. Now, naturally, variation shows the relationship between two or more quantities, or the relationship between two or more variables. Now, it determines how they are related. For instance, it could be that as one of the quantity increase, the other also increase. That is a what? A direct variation. Now, or when one of the quantity increase, the other decreases. That is what? An indirect variation. So in this class, we are going to be looking at four types of variation: the direct variation, the inverse variation, or sometimes called the indirect variation, the joint variation, and the partial variation. With the help of these four types of variation, we shall be discussing, you will be able to solve problems on variation in any examination question. Now, today we are going to be looking at the first type of variation, which is called direct variation. Now, how can I explain direct variation in a better way for you to understand? Take a look at, let's say a consumer goes to a market to get some pairs of shoes. Now, if Naira represent the price and QD represent the quantity demanded, if the price is 10 Naira and then the quantity demanded of pairs of shoes is 3. Let's assume that can't be possible, but let's just assume. And then the price increases from 10 Naira to 20 Naira. And then the quantity demanded also increase from 3 to 5. This relationship is a direct relationship because as one increases, the other also what? Increases. And as one decreases, the other also what? Decreases. That is the perfect way to explain a direct variation. So when you want to write a direct variation, shows the relationship between two quantities such as one of the quantity increase, the other increases, and vice versa. Now, for us to be able to understand direct variation, or inverse variation, or joint variation, or partial variation, there is some steps you need to take. You don't just start solving. No, you need to follow steps. And I'll be giving you 2 steps. With these 2 steps, I bet you can solve problems on variation. Now, the first thing you need to know when solving any variation question is that you find the constant of proportionality. The constant of proportionality, which is represented by letter K. That is the first thing you look for. Even sometimes they won't tell you to find K, which is the constant, but you must find the constant. Now, when you have gotten the constant, the next you are going to look for is the relationship. Now, some textbook calls it the relationship. Others call it the formula connecting. Another call it the equation connecting the variables, or the equation connecting the quantities. Now, with these 2 things, you are good to go. Now, what did I say? The first is to look for the constant of proportionality, and the second is to look for the relationship or the formula or the equation connecting these quantities. Now, we are going to be looking at just 2 examples to explain a direct variation question. 2 examples. Now, let us begin. Example number 1. Example number 1. Now, example number 1 says, if x varies directly as y, when x equal to 8, y equal to 4, full stop. Find, Roman figure 1, the value of x when the value of x when y equal to 10. Roman figure 2, the value of y when x equals to 2. Now this is the question, solution. Now, if x varies directly as y when x equals to 8, y equals to 4, find the value of x when y is 10 and the value of y when x is 2. Boom! Now you are given this type of question. What do you do? What do you start thinking? What comes to your mind? Now, some students just begin solving and don't know the steps to take. You must follow steps. Now, what did I say is step 1 you take? Find the constants of proportionality. Now, how do we get the value of k? Simple. Let's go there. Now, bringing back the question which says x varies directly as y. The next thing you do here is to introduce your constant. It becomes x is equal to ky. Now, this k now is what? Your constant of proportionality. Now, how do we get the value of k? Class, you will notice that from the beginning of the question, the value of x and the value of y was given. Why is it so? It was given for us to get the value of our constant. Now let's go on. Now in this place, x is 8 and y is 4. So what does that mean? Anywhere I see x, I put 8. Anywhere I see y, I put 4. So automatically here becomes 8 is equal to k4. Now if I'm looking for the value of k, I need to make k the subject of the formula. And what do I need to make k the subject? I divide both sides by 4. Class, when 4 cancel 4, what do we have left? Constant. Class, 8 divided by 4 will give us 2. Now, what does that mean? It means that the constant of proportionality to this question is 2. Now, I've got to step 1. What did I say step 2? Find the relationship. It is step by step. You don't have to be in a hurry. Step by step. Now, how do we get the relationship? Next. Relationship is, how do you get relationship? Class, watch me. This very place that you introduce your constant, that is where you get a relationship with. Now, anywhere you see k now, what will you put? The value, which is 2. So the relationship becomes x is equal to k now is 2, and what do we have there? Y. That's our relationship. Class, we have followed these 2 steps given. Now that we have gotten the 2 steps, let's come to Roman figure 1. You see, in the question, they did not tell us to find constant. They did not tell us to find relationship, but you must do that. Because when you don't do that, you can't get Roman figure 1 or Roman figure 2. Now, solving Roman figure 1, Roman figure 1 said, find the value of x. When you are finding x, what does that mean? It means x is unknown. We don't know it. Now, what is y now? Y is 10. Y is 10. Now, let's go there now. What will you now use to solve Roman figure 1 is the relationship. This is the reason why we solve for the relationship first. Now, using the relationship, anywhere I see x, I will still put x there because we don't know x. But anywhere I see y, I'll put 10. So automatically, x is equal to 2 brackets 10. And what does brackets mean? Times. Automatically, x is equal to 2 times 10, which is equal to 20. Using the relationship. Now, class, let's go to Roman figure 2. Roman figure 2 say now, find the value of y, meaning what's our unknown now? Y is unknown. Anything you are finding, you don't know. So it becomes a question mark. Now, when x is 2, class, x now is 2. What does that mean? What are we still using? The relationship. That's the key. That's the key to opening the door. Now, using the relationship now, anywhere I see x, what will I give now? 2, because x is 2. But anywhere I see y, what will I still give? I will still give y because I don't know what is y. So automatically becomes 2 is equal to 2y. Now, if I'm looking for y, what will I do? I will divide both sides by this 2. Here becomes over 2 and here becomes over 2. Plus, when 2 cancels, what do I have? Y is equal to 2 divided by 2 is y. That's the answer. Class, now you see why it is very important. It is very crucial and very necessary to get your constant and also to get your what? Your relationship. Example number 1. Let's go to example number 2, which is the last example for today. Class, example 2 says, if n varies directly as the square of n. The square of n is different from the square root of n. They are different things. Comma, when n equal to 16, n equal to 2. Full stop. Find, comma, Roman figure 1, the value of n when n equals to 1. That's what we're going to look at. Just that. Now, class portion. Without wasting time, what did I say are the steps we are looking at? First of all, get the constant. Secondly, get the relationship, and then you can solve. Now, let's get the constants, class. Using the question again, which says n varies directly as n squared. Introducing the constant, it becomes m is equal to kn squared. Now, mind you, I told you the first values of m and n must be given. Why? For us to get the value of the constant. So, what is m there? M is 16 and n is 2. So, anywhere I see n, I give 16, and anywhere I see n, I give 2. So, it becomes 16 is equal to k2 raised to the power of 2, because n is 2 raised to the power of 2. Now, class, 2 raised to the power of 2, we did lots of indices. 2 raised to the power of 2 means 2 times 2, and that is 4. So, here becomes 16 is equal to k4. Now, if we are looking for our constant, we divide both sides by 4. Class, when 4 cancel 4, what do we have? K becomes 16 divided by 4 will give us 4. We have gotten the value of the constant. Now, class, what else are we looking for? The relationship. Getting the relationship, class, put time. Relationship is, I told you, where do you get relationship from? The place you introduce your constant. Now, bringing this out, it becomes n is equal to, now what is k? K is what? 4. So what do I have? 4n raised to the power of 2. That's our relationship. Class, we were not told to solve for this, but you must solve for it. Now, class, let us now solve for our Roman figure 1. Roman figure 1 says find the value of n, meaning n is a question mark. Now, what is our n? N is what? Now, what did I say we will now use to solve this math now? Our relationship. Now, anywhere I see m and our relationship, I still give the value of m, and anywhere I see n, what do I give? 1. So here becomes n is equal to 4 into brackets 1 raised to the power of 2. Class, what do we do now? m becomes 4 into bracket 1 raised to the power of 2 means 1 times 1, and that is also what? 1. So class, without wasting time, n becomes 4 times 1 will give us 4. It's as simple as that. Class, now we have seen how direct variation question works. I hope you have learned something new today. Please don't forget to share this video. It will save life. It will save those people also that need something like this. In our next video, we shall be looking at inverse variation. Till we meet again, God bless you. Thank you.